All right, well, thanks for joining us today. My name's Joe Travellini. I'm one of the product managers on the Amazon EFS team.
And I'm Daryl Osborne. I'm a solutions architect with the Amazon File Services teams.
And we're going to go over a new cost-optimized storage class for Amazon Elastic File System called Infrequent Access. So here's what we plan on covering today. First, we're going to go over EFS at a high level for those that might not be familiar with EFS or need a refresher. Then we'll talk about the new IA, Infrequent Access Storage class, what it's designed for, how it works. And then we'll go over the relatively new AWS DataSync service and show how it can be used to quickly load data into an EFS file system. And finally, we'll go over any questions you might have. So with that, let's jump right in. So when we designed EFS, we had a couple of core tenets in mind. First and foremost, EFS is simple. So we removed the complexity of deploying, patching, maintaining any infrastructure needed to provide file system storage. And it's a fully managed service. It's super easy to use. With just a few clicks, you can create a scalable native file system in just seconds. And next, another tenet is that EFS is fully elastic, meaning you don't need to provision your capacity up front. Your file system automatically grows and shrinks as you add and remove files. And finally, EFS is scalable. So each EFS file system is able to grow to petabytes of capacity. And performance even scales automatically with the size of the file system if you wanted to. We do have knobs available for tuning performance if that's something you're interested in, and we'll talk a little bit about that in just a bit. And across these tenets, we designed EFS as a platform to provide highly available and highly durable data storage. So EFS is designed for 11 nines of data durability, and we offer a service level agreement that's targeting 3 nines of availability for your file system resources. Okay, so beyond those tenets, simple, elastic, scalable, let's talk a little bit more about some of the other features that EFS provides. First, from a performance perspective, EFS offers 2 different file system performance modes, a general purpose mode and another that we call max IO. So the trade-off between those 2 performance modes is essentially one has lower metadata latency versus the other having an operations per second limit. So GP mode provides the lowest metadata operation latencies that EFS can offer, while max IO mode is not subject to the IO limits and can provide the highest level of aggregate throughput that EFS can offer. So speaking of throughput, EFS also offers 2 throughput modes. There's the default bursting throughput mode, where throughput will scale linearly with the size of the file system and allows for periodic bursting above that fixed rate, as well as a provisioned throughput mode, where you can provision exactly what you need for more consistent and deterministic throughput performance. Another key feature is the shared access model of EFS. So you can access EFS across thousands of clients simultaneously and across multiple availability zones. And we also support accessing EFS across VPC peered connections, over VPN, or from a data center colo via AWS Direct Connect. And just one other highlight too, from a security and compliance perspective, EFS supports encryption of data at rest and in transit. And we offer compliance with a number of programs such as SOC, ISO, PCI DSS, as well as HIPAA, among others. Okay, so just a little bit more depth on how EFS works before moving on to talk about infrequent access. So to provide the high levels of availability and durability, EFS replicates data within and across availability zones. Under the hood, we're creating resources called mount targets, and those are in your VPC as a customer, and those are used to serve the EFS traffic. So you don't really need to have high touch points with your mount targets. If you mount a file system using its DNS name, and EFS actually provides a mount helper that makes this even simpler. You just provide the file system ID. We'll automatically resolve the DNS to the mount target that's in the same availability zone as your client. So it's co-located. You get maximum performance that way. You're not having any cross AZ network charges or anything like that. And there's no single points of failure. The mount targets themselves are also designed to be highly available. And then on the back end, file systems are distributed across an unconstrained number of storage servers. So you're avoiding any typical bottleneck associated with a traditional network filer. And EFS is available in 12 AWS regions all across the world, with more to come. Okay, so let's briefly talk about some of the economics of using EFS, and we'll actually go over a total cost of ownership model later on in the webinar. So it's pretty simple. There are no minimum commitments or upfront fees. As we mentioned earlier, no need to provision storage in advance, and there's no other hidden fees or charges that you need to worry about. Okay, so that's a quick recap of EFS overall. And now we're going to focus on the new EFS Infrequent Access storage class. And Daryl will demonstrate how to use DataSync to quickly load data into EFS and take advantage of all these cool features. So recall that, when you're using EFS, like I just mentioned, on top of it being fully managed, you're getting all those features, the high availability, high durability, elasticity, and scalability natively right out of the box. And customers often tell us they love how simple EFS is to use, but it can become quite expensive to store large amounts of data for long periods of time. So what we did, we went off and we looked at different ways that we could extend the lowest possible price point while still providing all those features that customers expect. So EFS has been in general availability for almost 3 years now. We have plenty of usage data to analyze. What we found is that most files that customers store in EFS aren't really accessed a lot. And they actually tend to be accessed less frequently as they get older. Basically, after they've been created, you might see a flurry of activity to start, an active workload, and then they kind of age off over time. And then they're not frequently accessed, but they need to be there. They need to be accessible and readily available when called upon. So right there was an opportunity. What if we could automatically lower the cost of storing files as their access patterns are changing and they, again, are tailing off and becoming accessed less frequently? So that's exactly what we did. So the Amazon EFS Infrequent Access, or EFS IA, it's a new storage class that can save customers up to 85% compared to the pre-existent storage class, which we're now calling EFS Standard. Customers can use EFS IA to cost effectively store larger amounts of data in their file systems. And by doing so, expand their usage of EFS to an even wider set of applications and data. In using EFS IA, just like EFS overall, it's super easy. It doesn't require any changes to existing applications. EFS provides a single file system namespace, and it's transparently serving data from both storage classes, Standard and IA. To get data into EFS IA, you're just enabling a lifecycle management capability for your file system, and that automatically moves files from Standard into IA, and by doing so, allows you to realize that savings of up to 85%. Okay, so how does it work? First, you just create a file system. Like I just mentioned, the file systems are transparently serving data from both storage classes. You have that common file system namespace, so you don't have to worry about which of your files are actively used and which are infrequently accessed. Then all you need to do is really just enable lifecycle management for your file system. And when you do that, any files that aren't accessed for 30 days automatically get moved from the EFS Standard class into the Infrequent Access storage class. So with both, the IA storage class and lifecycle management, we're eliminating the need to manually manage your data to optimize for cost. And again, all EFS features are supported in conjunction with IA. All right, so when should you use EFS IA? So let's talk a little bit about the use cases that we see. So again, generally speaking, EFS IA, we designed it to cost effectively store files that aren't accessed every day, but again, need to be readily accessible to applications. So we see, different applications with that profile in a number of different areas. For starters, sometimes, you simply need to keep files around, whether that's for a regulatory retention purpose or for satisfying an audit requirement. Other times, you might just want to keep a quick backup or failover site around and help you meet a tight recovery time objective, or RTO. And we also have customers running simulations and other types of iterative algorithms performing data analytics. So you see that in areas like genomics, health sciences, electronic design automation, geospatial analytics, in oil and gas. Like oftentimes those algorithms and applications need to reference a historical data set, which isn't accessed very often, but again needs to be readily accessible. And another area where EFS IA is a good fit is in the document management space. So things like legal research and HR staffing systems, they have a treasure trove of documents that mostly sit idle, but otherwise are well served by a file system in applications that expect file system compatibility. So it's a really, IA is a really good cost optimization measure for those types of use cases. So as I mentioned a little bit ago, we're now calling the pre-existent EFS product, our general purpose offering, the standard storage class. It has a super simple all-up price point of 30 cents per gigabyte per month. There are no network charges, no other fees, and you only pay for what you use. With EFS IA, it's cost optimized, again, for files that aren't accessed every day. So in addition to a storage price point, you also pay a fee each time you access or read or write to a file that's stored in IA. So this price structure allows us to extend the lowest possible storage cost for infrequently accessed files. In that storage cost, EFS IA costs 4.5 cents per gigabyte per month, and then access to IA files costs 1 cent per gigabyte. And those prices are in the US Northern Virginia region. EFS IA is priced similarly to EFS standard in other regions, and you can see that out on our website in the pricing table. Okay. So with the basics out of the way, I'm going to go a little bit deeper on how lifecycle management actually works. So like we talked about, there's a predefined policy that automatically moves files after 30 days of not being accessed. So for file systems that were created after the launch of EFS IA, you can enable or disable lifecycle management at any time. But keep in mind that once lifecycle management moves a file from the standard storage class into the IA storage class, that file will remain there indefinitely. So you can always bring it back by creating a copy of the file, somewhere else in the file system within the same folder, or different folder. If you find that, okay, now you have files that have become frequently accessed, you want to bring them back into standard, you can do that by creating a file. And you would do that for performance reasons, and I'll talk about that in just a minute. So for the purposes of lifecycle management in the IA storage class, what do we mean by data access? So what we mean is any read from or write to the file content. So EFS uses an internal timer that's tracking the reads and writes on a per file basis. Things like doing an LS, listing the content of a directory, any sort of file metadata operation doesn't constitute access from an IA perspective, in a lifecycle management perspective. So that doesn't affect the timer we're using internally to track the last time any file was read from or written to. So speaking of metadata, we're keeping file metadata itself, so things like the file name, the owners of the file, its attributes, access control, and so on. That's all stored on EFS standard. So we chose to do that to provide consistent metadata performance across files in standard and IA, right? So again, keep in mind, you have that single file system namespace, and what storage class any file is on is transparent to users and applications. And I'll talk again about IA performance in just a second, but we're also storing files that are smaller than 128 kilobytes. We'll always store those on EFS standard. So that allows us to provide the best user experience at the lowest possible cost. And that was based on our analysis of EFS usage patterns overall. So on the performance front, EFS IA has slightly higher first byte latencies as compared to EFS standard. You'll see on average single-digit millisecond latencies for reads and writes to standard, whereas you'll see double-digit millisecond latencies on average for reads and writes to infrequent access. That being said, you can drive the same level of throughput against files in IA as files in EFS standard. And it doesn't matter what throughput mode you're using, whether that's the default EFS bursting throughput mode, or if you're using EFS provision throughput. So one thing to keep in mind there is that your file system's baseline throughput, it's going to scale with the amount of storage you have in the EFS standard storage class. That baseline throughput, that's used to calculate your burst credits and your burst rate if you're in EFS bursting mode. And it's also used to calculate the amount you billed when using provision throughput. So for provision throughput, you only pay for the premium of throughput that you've provisioned relative to what you're entitled to with the EFS bursting model. So it's kind of the best of both worlds when it comes to that. And finally, workload priorities. So lifecycle management is the mechanism that's transitioning files from one class to another. Those transitions happen in the background and at a lower priority than active file system workload. So until a file is fully transitioned by lifecycle management into IA, it's stored on EFS standard and billed at standard rate. So speaking of billing, just a few more details on how we meter and bill for EFS IA. So EFS IA storage, just like EFS standard storage, is metered in 4 kilobyte increments. So reads from EFS IA and lifecycle transitions to EFS IA are metered in 1 megabyte increments. So you might have noticed, why did I say lifecycle transitions and not writes? Well, I kind of mean the same thing by that. So all writes to EFS first land on EFS standard, and then lifecycle management transitions them from the standard storage class into the IA storage class. So if you update, if you write to a file, you overwrite a file, append to it that's in EFS IA already, lifecycle management will transition that updated file content a maximum of once per day. And then finally, when you look at your EFS bill, you'll see your infrequent access storage, split out separately from your standard storage, and you'll also see read requests and write requests to IA broken out separately. So when you see a write request on your bill, what you really are seeing are the lifecycle management transitions of file content into IA. Okay, so that's it really, just in terms of what EFS IA is and how it works. It's really easy to get started. You just create a file system and you click the checkbox in the console to enable lifecycle management. Cool, so now we're going to talk a little bit about AWS DataSync, and then I'll hand it off to Daryl to show live how we piece the puzzle pieces together to make this all work in Confluence. Okay, so what is AWS DataSync? Fundamentally, its name, as its name reflects, it's a online transfer service. So what we're doing with DataSync is we're combining the speed and reliability of traditional network acceleration techniques with the cost effectiveness of open source software. So you can use DataSync to transfer at up to 10 times as fast compared to open source tools. So it's really fast, it's easy to use, it's secure and reliable. It's natively integrated with services like EFS, and it's cost effective. So here's a little diagram on how DataSync works. So it's compatible with NFS file systems, including EFS. You'll deploy a DataSync agent, you typically on premises. Darryl will show you some things we have in the pipeline coming soon. It uses TLS to securely transfer data to the DataSync service endpoint, and then from there it's optimized to read from and write to both Amazon S3 as well as Amazon EFS. So under the hood, DataSync is using a purpose-built protocol. It's multi-threaded. It takes advantage of parallelism. It can scale across multiple agents. There's some optimization techniques in terms of incremental transfers, compression, sparse file detection. So you're only sending over the wire what absolutely needs to be sent to get the job done. And like we talked about before, integrated with both S3 and EFS to be native and optimized. And you can also configure, there's some knobs to tune on throughput and other sorts of performance characteristics. So DataSync helps you simplify the management of moving data. You can set it up in the console, or you can use a programmatic technique like the AWS CLI, the command line interface, or the SDK, the software development kit. There's really minimal infrastructure to deploy or manage in AWS. You have that agent, but that agent is fully managed in terms of updating its software, providing patching. That's not something that you really need to care and feed. That's all automated and streamlined for you. And you don't have to get into the business of building a manifest and preserving, your file system structure. Like that metadata across different storage systems and storage services is all handled by DataSync. So in addition to transferring, transferring over the wire using TLS, DataSync also supports the key management service, or KMS, for encryption of data at rest with the various AWS services, namely S3 and EFS. It can access services within your VPC. It has built-in validation and automatic recovery from any sort of failure in transmission. And on top of just the S3 and EFS integration, you also have integration with things like Amazon CloudWatch for monitoring. You can use CloudWatch logs, you can track your data movement, you can audit your usage. It's integrated with IAM permissions, so you can kind of lock down which of your users can perform these activities. And you have CloudTrail to audit the API call stack as well. Likewise, DataSync is also compliant with PCI DSS and HIPAA and other compliance programs. Finally, it allows you to save money. It's cost effective. So you only pay for 4 cents per gigabyte of data transferred. And like EFS itself, no minimum commitments, no upfront fees. So just for example, if you wanted to transfer 100 gigabytes of data into EFS, that would cost you $4 using DataSync. So the service infrastructure is fully managed. It scales automatically. The one piece that you're responsible for is the agent, but we'll show you some tips and tricks on how to optimize and streamline that in just a second. But those agents, again, are automatically updated and patched. Okay, so with that, I'm gonna hand it over to Daryl, who's gonna walk through how to piece these things together.
Great. Thanks, Joe. Some of you may be wondering why we're talking about AWS DataSync in an Amazon EFS IA webinar. Well, as Joe mentioned, AWS DataSync is a great way to quickly and securely ingest or transfer data from on-prem to AWS. But soon you'll be able to do these transfers to and from in-cloud resources. This will include transferring files from an EFS standard file system to an EFS Infrequent Access file system that has Lifecycle Management enabled. So we know and understand that there is a need to transfer files, data to and from different storage platforms. And we also know that transferring large amounts of data is difficult. That's why we built AWS DataSync. But we know and have heard from you that you want to use AWS DataSync to transfer to and from more storage platforms, specifically EFS to EFS, in-cloud NFS running on EC2 to EFS, objects in S3 to EFS, and objects in S3 to in-cloud NFS on EC2. So there are a number of reasons why you want to do this. It could be for disaster recovery purposes, or loading data from an object store to a file system for data analytics, because most of these applications require file system semantics to this data. Your application may be distributed across multiple regions, and you want your file data to be eventually consistent across all these regions. Or you could just be migrating data from one file system to another. To leverage this new functionality, you'll be able to deploy an AWS DataSync agent as an EC2 instance using a specific Amazon Machine Image or AMI. This will open up new source locations like in-cloud NFS on EC2 or EFS or even S3. Keep in mind that with AWS DataSync, a source and destination location could be in different AWS regions, or they could be in the same region, but not all source and destination combinations are supported. One use case for this functionality is to use AWS DataSync to quickly and securely transfer file data from an EFS standard storage class file system to a new EFS file system that supports the Infrequent Access storage class and Lifecycle Management. So this architecture could look something like this. First, you have your source region, and within that source region, you have your source Amazon EFS file system. In the destination region, you have your destination EFS file system. And remember, the source and destination file systems could be in the same region. In the source region, you launch an EC2 instance using a specific AMI that runs the DataSync agent. Then you create and configure DataSync resources using the DataSync service in the destination region. This will allow you to transfer file data from the source EFS file system to the destination EFS file system. To create and configure the DataSync resources in the destination region, you identify the DataSync agent running in the source region. You identify the source location, which is the source EFS file system. And you identify the destination location, which is the destination file system. Then you create a task to transfer your files using these DataSync resources. To help you get started using AWS DataSync in cloud transfers, we've created a quick start and scheduler. This is an easy to launch AWS CloudFormation template that creates a stack with all the required resources, including the AWS DataSync agent EC2 instance and the optional scheduling mechanism used to schedule the transfer of this data. Before you launch the AWS CloudFormation stack, you need to have the source and destination file systems already created. The first version of this quick start and scheduler supports transferring from an in-cloud NFS source, either NFS on EC2 or EFS, to an EFS file system. There is no additional cost to use the quick start and scheduler, but you're still responsible for any compute, storage, or data transfer charges that it creates. To give you a glimpse of what the quick start looks like, let's take a look at a diagram. Here's a diagram of the environment that it creates. You launch the AWS CloudFormation stack in the source region. The source and destination regions could be in the same region, but if you're setting up cross-region replication your file system, you need to launch the stack in the source region. The source and destination file systems must already exist, but the CloudFormation template creates the rest of the environment. So let's go ahead and take a look at this in action. So I'm going to hop over to the AWS Management Console, and we see here that we don't have any CloudFormation stacks created. We also see that within DataSync, if I do a refresh, we don't have any DataSync resources created here either. But I do have two file systems. I have a file system that does not support the Infrequent Access storage class. So I don't have the ability to enable Lifecycle Management. And I also have a second file system that does support the Infrequent Access storage class, and I have a Lifecycle Management policy enabled for this file system. So what I want to do, and you can see the size of the file systems, I have approximately 167 gigabytes of data that I want to transfer from my EFS standard storage class file system to my EFS Infrequent Access storage class file system that I have a Lifecycle Management policy enabled for. So let's go ahead and set up and use the AWS Quick Start and Scheduler CloudFormation template to create a task to transfer this data from one file system to another. So from the CloudFormation Management Console, we click on Create Stack, and I actually browse out to where I have this stack, this template created. So it's just local on my machine. I'll go ahead and open this up and click on the next step. So from here, I actually have also a parameter file created that has some of these parameters already set up. So I use this when I automate some of the creation of the stack. So I'm going to go ahead and flip over to that so I can get some of these parameters. So the first thing I want to do is just go ahead and create a name of the stack. So I'm going to hop back and forth. I'm going to enter the name of the stack here. Next, I want to assign the EC2 key pair to the AWS DataSync EC2 agent. So again, this is an EC2 instance that is running the DataSync agent. So there's a specific AMI that's going to be launched for this. I'll go ahead and select my EC2 key pair that I want to use. I select the instance type, so we recommend starting with the C5 2 extra large. There are other instance types that have similar network performance characteristics and attributes, but for this example, I'll start with the C5 2 extra large. Then the source subnet ID. So again, this is the subnet ID that the AWS DataSync agent is going to be launched in. So this subnet ID will need to have access to the source file system. So in this example, I'm just going to go ahead and select my friendly name subnet. And I'm also going to select a security group that, again, also has access to the source file system. So again, I'm going to select my friendly name security group. Now, the source NFS file system needs to be identified here. So because we are creating an NFS location for the source, we need to include the DNS name of the file system. So what I want to do is go back to my EFS console. I'll select the DNS name of the source location. I'm going to paste that here. Now, if there's a specific subdirectory that I wanted to only copy that data over to the destination file system, I could enter that in here. I'm going to go ahead and transfer the root or everything in this file system over. Next, I need to identify the destination location of this file system. The destination region. So what we're going to be doing is I'm going to be transferring within the same region. So I'm going to select a US East 1 here as well. Next is the destination file system. So here I want to go ahead and select the file system ID of the destination file system. So we'll go ahead and copy that and paste it into here. Next, the subnet ID. So again, this is a subnet that has access to the destination EFS file system. So I already have this information in my parameter file. So here's the destination subnet ID. I'm going to go ahead and grab this and paste it into my CloudFormation parameters. And a security group ID as well. Again, this security group ID needs to have access to the destination EFS file system. I also have that stored here as well. If I wanted to copy or transfer this data to a specific directory within the destination EFS file system, I could go ahead and identify this here, but I'm just going to go ahead and transfer from root to root, from source to destination. I could also set up a schedule of when this task should run. Maybe it's on a regular basis, maybe every 30 minutes. You want it to sync these two file systems, or maybe if it's a one-time. So if it's going to be a one-time, what I recommend is go ahead and set it in a date that is far in the past. So you can actually set this to January the 1st, 1970, which what I did here. So the scheduled task will never run. So what I'd have to do is actually manually start the task in order to for the task to run. If I change this and want it to run every 30 minutes, I could go ahead and do this. This is using a standard cron expression. I'll go ahead and click on next. Review any of the stack options or advanced options. Don't have to make any changes here. Click on next again. Do a quick review of everything that I've entered in as my parameters. I'll go ahead and click accept, and I am going to create some IAM resources, and click create stack. So it'll take about 3 minutes for this stack to be created. So let's actually go back and take a look at what's being created as a part of this stack. So as you see here in the diagram, and I'll move my cursor, the AWS CloudFormation stack is being created in the source location. So this is where the source file system resides. It is right now creating an EC2 instance. This EC2 instance is based on an AMI that is running the DataSync agent. I identified the security group and subnet ID where this agent is going to reside, and both the subnet ID and security group needs access to this EFS file system. As a part of the stack, it's also creating an SSM document and SSM maintenance window. These are the scheduling mechanisms that it uses to actually schedule this on a regular basis. Once this environment is set up and that agent is running, it will actually create the DataSync resources in the destination region. So it's going to set up the agent, the location, the source location, the destination location, and create the task for you based on that source directory and the destination directory. So all of that will be created as a part of this. So after about 3 minutes, you'll be able to see that you have the CloudFormation stack completed, you have an EC2 instance running, and you have all of these resources created within the destination region. So let's hop back to the management console and see where we are with the creation of the stack. So we're getting very close. We're about 2 minutes. We're about 2 minutes into it so far. So if we take a look at the DataSync resources in the destination region, again, the destination source region in this example are going to be the same, but we see that we don't have any resources created yet because it hasn't gone to that part of the CloudFormation stack. Very soon, though, you'll be able to start seeing some of these resources being created. Also, it will create the EC2 instance. This is going to be the EC2 instance that's running the DataSync agent. And again, very soon you'll be able to see an agent being launched here and running within the destination region. So if we go back and we do a quick refresh, we'll see how close we are. So the agent fleet has been created. So very soon we'll be able to see an EC2 instance being launched here. Then within a few minutes, we'll be able to see the entire, well, really within the next few seconds, we'll be able to see the entire stack being created. So right now it's creating the task execution task, which is the SSM maintenance window. Then within a few more seconds, it'll be completed. Now that the task is actually, or the entire stack is created, we should start to see the instance being launched. There it is. We see the instance is initializing. It's in a running state. So within the next few minutes, this instance will be running. We could take a look at our DataSync resource. So again, this is going to be maybe another 30 seconds, maybe 45 seconds. We'll start to see some of these resources being created. If we go back to the CloudFormation stack, I created some of the outputs, which is very, what I think useful for users as you want to manage the stack. So first, there's an SSM command that you can run to actually disable the task execution schedule. So if you need to disable that schedule for any reason, you can go ahead and click onto this, copy this into a command shell window, and go ahead and execute this, and this will disable the maintenance window. If you want to enable the maintenance window back, you can go ahead and run this other command. If you want to run the command just on demand, there's also an SSM command here that you can execute that'll actually start that transfer. You can either do it here using an SSM command, or you can go into the DataSync service at the destination region and go ahead and just start the task yourself. You also have a command here that actually updates the schedule if you needed to change the cron expression to change that scheduled command. This is useful too, is because this is a command that we can run within a shell window. And what this does is this will actually run an SSM command against that instance, and it'll actually take a look and return the log file that's created when it's creating all of those DataSync resources at the destination. So we see that it created the agent, it created the source location and the destination location. So all of these resources have been created now. So if we go back to the console, if we go ahead and refresh the DataSync in the destination region, we'll see that we'll have a task created. We have the two locations. We have our source location and our destination location, and we have that agent is online. So everything is ready for us to actually kick off that task. So let's go ahead and do that now. So we can go ahead and select that task, and we can start this task. So right now that task is running. We can take a look at the history of this task and see how it's actually performing. So you'll notice that the status of the task is going to change from launching to actually starting to transfer some of that data. And we'll see how fast we're able to transfer data from this EFS file system, the standard storage class EFS file system, to a storage class file system that's, or a EFS file system that supports the infrequent access storage class. So now it's in the preparing mode, and here within the next few seconds, we'll start to see some megabytes per second throughput here displayed in the history of the task. While it's doing that, let's go ahead and go to the management console. I'll show you some of the resources that it created, the stack created as a part of that. So this is the mechanism that it actually schedules the execution of that if you set up a cron expression within the template. So this is the expression that I used. I could go and actually change this and to have a different schedule, or I could disable this the scheduled event altogether, and I can re-enable it here as well. So you can manage the scheduling aspect of it using the SSM maintenance windows, or you can manually launch the task using the DataSync service in the destination region. So let's go back to the DataSync and see how we're going. So right now we've already transferred 7% of the data. We're at around 210 megabytes per second throughput. So we're transferring a lot of data from this one file system to another. So it'll take, I think I tested this, it'll take about 12 maybe 15 minutes to transfer the 167 gigabytes of data from this one file system to another file system. At the end, it'll verify on both file systems, make sure that I got all of the data transferred over. Then the task will stop. At that point, we can go ahead and delete all of these resources. So keep in mind though, because not all the resources were created as a part of natively as a part of the CloudFormation stack, it's recommended that you use this method to delete the resources. So at the very end, I actually created an SSM command that creates the delete commands to delete these resources. So if I actually go ahead and copy this into a shell and run this, you'll see the delete commands that you want to run. So to actually delete all these resources in the right order, go ahead and copy this, paste it in another command shell, and execute it. So first, it'll delete the task. It'll then delete the locations, the source and destination locations. It'll then it'll delete the agent. Then it'll delete the CloudFormation stack. So by the end, you'll have none of the AWS DataSync resources created or running. And the only thing you'll have is your source and destination file systems, but now with all the data from the source in the destination file system. And that's it. So pretty easy to get up and running. We have this quick start and scheduler ready. The user guide has all the documentation to walk you through this step by step and give you some pretty in-depth details on how to use it and all the different settings and the parameters that you need to use when you launch the stack. So let's walk through a quick TCO example of the infrequent access. So, before we said, EFS was about 70% more cost effective than a do-it-yourself setup. So if we update this example to include EFS IA and a cost optimized do-it-yourself setup with multiple storage tiers, you can see that EFS with IA is closer to 90% more cost effective than building it yourself. And don't forget, these are just your hard costs. Soft costs like managing the software, patching your infrastructure aren't included in these in this TCO analysis. Let's take it one step further. So here's a TCO example of the AWS DataSync in-cloud transfer quick start and scheduler that I just ran. So I say we want to use this to migrate data from an EFS standard storage class to an EFS IA. So again, in this example, 500 gigabytes of data in the standard storage class would cost $150 per month. If you wanted to take advantage of EFS IA and get your monthly storage costs down to $52 per month, because 400 gigabytes of data is actually infrequently accessed, you would use the AWS DataSync in-cloud transfer quick start and scheduler to transfer all 500 gigabytes of data to a file system that supports EFS IA with Lifecycle Management enabled. This one-time transfer would cost about $20.20. Once you're done with the transfer, you can shut down that CloudFormation stack. All those all the resources created as a part of that transfer will be deleted, and now your EFS cost would be $52 per month once your data has been transitioned from the standard storage class over to the infrequent access storage class. That concludes the webinar today. What I'd like to do is open it up for some Q&A.